Hello everyone, welcome back. So in this video we are going to understand 2975. It's a maximum square area by removing fences from a field. We have to find the maximum square area that we have seen yesterday. Similar to that, this is the questions we have. So we have to remove some fences from a field. If you remember the study problem, right, we have seen that we have to remove the rows and columns, and we have to make other square in such a way that we have to find the area, right? This is the similar kind of problem where what we have given, as you can see, we have given m and n, right? So m and n forms a rectangle field, right, at the corner. So just this is a simple difference, and we'll understand some more little changes that we have given this problem. So if you go through this example, it will be better for us, right? So and then we will try to understand one by one. Okay, so very first, this problem that we have given maximum square by removing fences from a field. So what we have given a rectangle, a large rectangle, you can say, field with corner 1 1 and there is two corners given. Let's suppose the very first corner is 1 1, and this is m and n, right? So if you will form a rectangle, right, and if you'll convert into the cells, right, we can say that this is a cell. The very first cell is nothing but 1 comma 1, that we know, and whatever we have given m and n, right, two things will be given, right? From there we have to say that there is another field, cell, we can say, that become m and n, right? So this is the very first corner and this is the last corner we have, right? That is the question is saying that the very first one is saying that we have given the rectangle, and then we have given, let's call the horizontal fences at certain y positions we have given. As you can see here, these are the positions we have given, and there are some vertical fences we have given. Okay, we can say that it's a certain x positions. So where it will be the x position, that we will understand. So if you convert into the coordinate system, you will understand that we have given a rectangle field like this. So it is saying containing horizontal and vertical fences. We have given these two things we have given. As you can see, we have given two things. After the rectangle, what we have given horizontal fences and the vertical fences at a certain y position and x positions, we can say that, right? Now these fences divides the field into many smaller rectangles, as you can see here, right? So you are, let's suppose, if you are allowed to remove some of the fences, we'll remove these two fences, right? And from the horizontal will remove these fences, and vertical will remove these fences, right? Can we say that this will make this one, right? Yeah, we can say that, right? So if we are allowed to remove some fences, right, so after removing them, you want to form the largest possible square, right? Not the rectangle. Make sure that not rectangle. Okay, we have to, after removing the fences, right, after removing them, we want to form the largest possible square, which is like this, and not the rectangle. Make sure that. So we have to return the area of this square. If no square is possible, we'll return what? -1. This is what the question is saying, that, right? Let me go through, right? Till that we have given, it is saying return the maximum square field that can be formed by removing some fences, or return -1, right? This is what the question is saying, guys, right? Since answer may vary large, you can take modulo 10 to power 9 plus 7, right? Let me show you how. Give me 1 second, guys. If you see here, you can see, right, it is impossible to make square field, then we will return -1. Otherwise you will remove the maximum area of the square of the field, and we have to take the modulo of 10 to power 9 plus 7. Okay, the field is surrounded by the horizontal fences, this like this and this to this, right? This is what the four coordinate system we have given, and we have to make these are the coordinates that these fences cannot be removed, right? Means what we have understand? We have understand that we have given the rectangle fields and the horizontal, let me show you, and then we have given horizontal fences and vertical fences. So this is called a y positions and this is called a at the x positions, right? So these fences divides the fields into many smaller rectangles. So what you need to do, we are allowed to remove these fences, and after removing them we have to form the largest possible square like this, not the rectangle, and after removing them, right, we have to form the largest possible square which is not rectangle, right? So it is, if the square is not possible, we have to return -1, otherwise return the area of the field, maximum area of the square field, right? We can say that. So this is what we have given guys in the questions, right? So let's try to understand first. Okay, let me zoom out. Okay, so you pause this video and try to understand what we have given. So you know that it's very important to understand that what square needs. A square needs what? A square needs same width, right, and height. I hope you knows this, right? Same width and same height. That is why this field, this field, this field, this field, or these sides are equal, right? This is what the square says. So the problem becomes, can we find the same distance between two vertical fences, right? Two vertical fences and two horizontal fences. In both cases, either through these fences and these fences, right, it can, we know that we can find the same distance between two vertical fences and horizontal fences. But how? Yes, we can. If the distance square is a square area, we can find it easily, because if you see the, this is the distance, let's suppose, sorry, so okay, so this is the distance from here to here, right? Who divides this width, right? The vertical fences. The vertical fences that it is going, it split the width, right? If I'll say about the horizontal fences that we have given, is split the height, right? The height of this square. So we can remove these fences, these fences, and then we have to merge the segment that we know yesterday, right? That we have seen yesterday. Because after removing the fences, right, the square will be formed, right, which is similar to this. So the golden reason that we can say here is the largest square we can form through removing the this part, we can say that, right? Let's understand, if we know the distance from here to here, right, then we can easily do that, right? But this distance is divided by either horizontal vertices, and height is only divided by the vertical horizontal fences, and width will be vertical from the vertical. So how the distance are calculated, that we should understand now. Okay, so let's think that how to find the distance, right? Or how we will calculate the distance, right? Let's think that in the very first step, right, what you need to do is add the border, right? So if we have width, let's suppose called w, and height we have is height. So if we have given, so we will add 0 and w to vertical fences, and then we will add 0 and h to horizontal fences. Understand? So this will ensure edge to edge distances are considered. Okay, understanding or not, right? What you will do, that it's ensure that the edge to edge is calculated, right? Now we have to find the gap. So now you will compute all possible gap. Okay, if you remember study problem, right, we have told you how to find the gaps, right? So let's think. Now think that for vertical fences, the possible width is, what is the possible width? Means all distance between, we can say, fence at I and fence at J. If we know we have given the fence at I and fence at J, we can find the width, right? We know that. And this is, we have given these fences, we have already given width fences, horizontal fences and vertical fences we have given. So we can easily find the width, we can say, the possible width we can say, and similarly we will find the possible heights, right? So can we say that the possible height are all distance between, we have to find the fence at I between the fence at J, right? If you are given, means we have to calculate the distances between the fence at I and fence at J. Like this, similar to this, we have to calculate this, right? Now the thing that we should understand how we have to find it, the gaps. You have to take one pointer, right? And you have to find the from the one pointer you have to scan the width gap, we can say that, like this. Let's suppose what is the gap is there. Then you have to take one pointer and you have to scan the height. So two pointer, one pointer, pointer 1 we can say, and pointer 2 we can say that. We'll think later how what we are going to choose. When the match found, right, let's suppose this pointer that is going to find the width, right, let's suppose called W, and when the pointer 2 going to find the width 2, let's suppose. So if this width and this gap and this gap are same, right, means we found the square. This is our intuition, you can say that, and how we should approach the problem that we should understand. Okay, now you will say, okay, give me 1 second. So how you understand this solution? Okay, so I'll say, just take a simple thing, any square, right, any square should have the side, let's call the side, it should be the some width, right, some width gap, that is called gap, it is equal to some height gap. If both are equal, like this is the gap, that is called the width gap, and this is the gap, this is the height gap, right? If this width gap and this height gap both are same, it's our side, right? So any square that gives the side which is equal to the width gap and the height gap is equal to, that gives you the side, right? So what you need to do then, once you will find the side, you need to store the all horizontal gaps we can say, and vertical gap, horizontal gap and vertical gap. Then we should find the common gap. If you find the common gap, your answer is ready. Gap into gap. From the 3 steps you will find the gap. Means first you have to find the side, then you have to store the horizontal and vertical gaps. Once you find the once you store those all horizontal gap and vertical gap, now you have to find the common gap. Once you find the common gap, you know that this is my gap, right? And then you will multiply gap into gap, that is your answer. Let's go to the code and try to understand, guys. Very better will go through the finding the separate horizontal sides. So all the possible horizontal sides length we will find through the get edges, and for all the vertical size, right, edges, we will find the vertical edges, right? Means there are two things we need to do that, right? And you have to take the mode, so you will also take the mode. Okay, then we have to find the max side, or you can say the side from the over the edges height length, and we will calculate over the vertical edges what is the maximum one. If we will find, means we know that this is our common side, that is that will iterate it over the array, and it will become the max side, right? Then we'll calculate similar to that we know already, right? Means how we are calculating the get is and get is how we are going to calculate over the array. So we'll create a common function here, right, like this, as a utility function, as you can see, where you will provide the fences and the border, right? So basically it will return the possible segment length by removing some fences. So for that you will need edges and the points, we can say, and you will add the field on the boundaries, like as I told, one you will take, it is a one based, so you have to add one, not the zero, and then you have to add the border that we have given, right? These things, once you will add the fences positions, right, you will keep adding the points on the fences. Now once you will have the everything ready on the points, right, what you need to do, you have to do collection dot sort. You will sort it as we were doing there, right? Then we have to compute all the distance, guys, right? How will you find the distance? You will have to find the gap like this, and you will add on the edges. As simple as this is a simple function we have created, and then we have done. So let me show you again. Kya karna hai? We have given two things, heights we have given and vertical fences we have given, m and b we have given, right? So from there, you through the m, right, we will find the fences and m. So this, let's suppose this is our border, given border, right, we can say that. And for the height and the m and n, we can say that height and width. So you will calculate for the height, you will calculate, you will use the m border, and from the vertical, right, we'll use the n, and then you'll find the max. And once you find the max height, you will know the what you call the area, right? So thank you guys, thank you for watching this video, and I'll put this code into the comment box, you can get from there. And thank you, bye bye. I'll request you try the time and space complexity. I'll suggest that you know that we have to find 2 times the get edges. So what we will, the space complexity and the time complexity. I'll write that both. Please write in the comment section. I'll put in the comment section. Thank you.